you guys how to find the calculator trick, the TI-84 calculator trick for confidence intervals for proportions particularly. And this is just for proportions with one population or one sample, okay? We're not dealing with the 2 case at Nightingale. So everything, like I said earlier, everything is either in stat or bars, like second bars for us, but this is in stat. So when you want to pull up your calculator trick for your confidence intervals, you're going to go to stat. And you want to go to tests now. So tests is where a lot of good stuff is. So scroll over to tests, and you're going to see a lot of stuff up here. Make sure your students go past this. Anything that ends in test is going to correspond to hypothesis testing. Anything that ends in interval or int is corresponding to a confidence interval. And a lot of semester students confuse the two. So if they ever have an issue, sometimes they're actually in the wrong thing, because the beginning of it is the same, it's just that the end is different. Interval, and then test at the end of it is hypothesis testing. So, it's actually pretty nice and easy. It's pretty nice and easy because everything kind of tells you like what it's for. So, for example, if I'm dealing with a proportion and I'm dealing with one population, the one prop z int, and I want a confidence interval, this is what I'm going to use. Proportion, prop, one sample, one population. Obviously, we're using z-scores. Int for interval. I want a confidence interval. And I'm just going to randomly make up some numbers. So everything is here. The number of successes, let's say, is 5. Number of trials, let's call it 25. And let's just say I want to find the confidence level, 95% confidence interval, and then calculate. And you'll see that your output, this is the nice thing about this too, the output is an interval notation. So this is the lower end and the upper end, open interval. And then p hat is your sample proportion too. So it also calculates that for them. And then your sample size. The only thing that I want to remind you too is that if, and I'm going to go back to stat and back to test and back to one prop, zint. The only thing is that sometimes the problem gives you the sample proportion instead of the actual number of successes. And sometimes, I don't know, let's see if it was like non-whole number, okay? I want you to notice that if we're trying to find like a percentage of a value, we're trying to calculate the number of successes, and it's not a whole number, you're going to see that the calculator is not going to understand that. So what's going to happen is if they're given, scroll down to what props the end, if they're given the sample proportion instead and they have to calculate the number of successes, they're going to have to round it, which means there's going to be slight, right, error in their final conclusion. But this is not going to take a decimal because it's obviously discrete, right? So just think about that when you guys are talking about the confidence intervals and the calculator trick, that x has to be a discrete number. And if they're given the sample proportion instead of just x, and it doesn't come out to be a whole number for x, then they're going to have to round it. And then it's obviously not going to be perfect at the end. So that's it for confidence interval for proportion.